Okay, this is an example of what we mean by abutting cells so that the cells can fit side by side without design rule errors. I'm going to open up this thing from Harvey Mudd College, look up the NAND inverter or NAND gate just to look at it. There's our NAND gate. There's the layout of the NAND gate. And what we're going to do is we're going to make a new cell in this library. I'm going to call it abut schematic. And in that schematic, we're going to just place two NAND gates, hook them together so we can do all of our testing. Copy, paste. I'm going to attach input A to B and B to that also. It looks weird, but that is our schematic. So we can also do some electrical checking. F5. Checking schematic cell, no errors found. That's what we want. All right, so new cell. We still call it abut, but we're going to make it a layout. Technology, MOS, CMOS. That's exactly what we want. So here it is in the viewer. Abut, that's our thing. This is our schematic. We would also make an icon for this, but we don't need to right now. There's the layout. In the layout, well, we need two NAND gates. These are NAND2 underscore X1s. I'm sure there's a way to apply these to there a little automatically, but I'm just going to find them components, cell. This is in the layout window, NAND2 X1. There's one of them. Copy, select, deselect, paste again. Now it looks like these are abutted with the edges. They are not, in fact. If I select this and say one level down, now I can see what's inside that. Select the other one level down. You can see that these layouts are not actually abutted together. I want to make the metal lines attached together. However, this is electric. Electric goes with connectivity. It will give errors if these GNDs are not tied together with a arc, with an ARC. That's what electric says. So I'm going to select this ground node, hold down the right button, draw this over, and you hear the little click. There it is. That's our wire to make sure they're connected, and so electric knows we want them connected. Like that also. All right, and now we'll go ahead and wire these nodes up here. So remember, it was the output of 1 was connected to both A and B. Well, the way this is connected is we can connect Y. Whoops. Select that node, right click, bring it over. Now node Y goes over here, connects to A. It's great. It's a wire, but we drew the metal here in metal layer 1. I hit F5, it says it found 4 errors. We'll step through to see which one it was. It says notch and whale, blah, 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 rule 1.3 Moses. If we check that, we can go to Moses. And we say IC fabrication, processes, on semiconductor, processes here, mixed mode C5, that's great. And on semi C5FN rules, lambda, and so on. These are the ones we needed a NDA for. SCMOS sub-M, submicron rules, lambda is 0.3 or 300 nanometers. Moses in PDF, SCMOS, whatever. This is our rules. And remember, that was rule 1.3. Control F on here, 1.3. Go down, that's not it. All right, so rule number 1.3, minimum spacing between wells at the same potential. So an N well and an N well, or a P well and a P well also. Sub M has to be 6 units, 6 lambdas. And it is not. It's like 1 unit. We can see that here. See that here. I'm sure the other 4 errors are the same. That's fine. How about we take this and just drag it over 1 notch. You see that closed up the gap. F5 again. And it says 0 errors and no warnings. That's wonderful. What if we say tools, NCC? The DRC is what we check. That's the design rules, the physical ones. We do that often. We also want the NCC, schematic and layout views of the cell in the same current window. Make sure the schematic matches the layout. What's it say? Oh man, it doesn't work. Parts and wires and blah 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 blah. We can look at that later. We really want to connect output Y to B here. And can we do that? Really? No. No. Let's add a via metal 1 to metal 2 connection. Right here maybe. Wire. Do there. Select metal 2 over here. Now we've connected node B. Here this is a via. This goes from metal 1 up to metal 2. We're going to go to our 3D window. Look at the 3D view of this. And we're going to look for this via here. And we can see right here is the connection here. And also these little pins, we're already up to metal 2. We could have used that if we wanted. Select metal 2 and draw it over there. But it skips over the output node. So 3 errors found. What are these errors? This is spacing, metal 1, metal 1, metal 1, 2, contact, Moses 7.2. Okay, whatever. That's not the abutting that I want to show you today. I'm going to take this and I'm going to drag it over. Drag it over, drag it over, drag it over. Trying to get these diffusions to match. This is what I mean by they match and they abut. So we're going to have some electrical rules. DRC is related to all these connections. Let's just delete them for now. Not that one. How can we select our VA here? No. Whatever it is. Okay. So that's the abutting. We want these to go over here. Do you see how the wires stay there? That's really nice. Oh my goodness, that's really nice. So abut, 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 and we're done.